Hi, my name is Kainton Munonye, and today we are going to be discussing Develop Schedule. Previously, on the Project Time Management knowledge area, we looked at Estimate Activity Durations. And today, we are going to be looking at what is involved in developing the complex project schedule. According to the PMBOK Guide 5th edition, Develop Schedule is the process of analyzing activity sequences, durations, resource requirements, and schedule constraints to create the project schedule model. The key benefit of this process is that by entering schedule activities, duration, resources, resource availabilities, and logical relationships into the scheduling tool, it generates a schedule model with planned dates for completing project activities. Developing an acceptable project schedule is often an iterative process. The schedule model is used to determine the planned start and finish date for the project activities and milestones based on the accuracy of the inputs. Schedule development can require the review and revision of duration estimates and resource estimates to create the project schedule model to establish an approved project schedule that can serve as a baseline to track progress. Once the activity start and finish date has been determined, it is common to have project staff assigned to the activities review their assigned activities and confirm that the start and finish dates present no conflict with resource calendars or assigned activities in other projects or tasks, and thus are still valid. As work progresses anyway, revising and maintaining the schedule model to sustain a realistic schedule continues throughout the duration of the project. Alright, let's now take a look at the inputs, the tools and techniques, and the outputs of the Develop Schedule. The Develop Schedule have quite a lot of inputs, tools and techniques, and the outputs. Some of these inputs you've seen them before in my previous presentation, and I think we can just read through them. The first is the schedule management plan, which was created as an output of the plan schedule management process. Resource calendars, resource breakdown structures. Remember, the resource breakdown structure is an output of the estimate activity resources process. Activity resource requirements, activity lists, activity attributes. Also remember, define activities generates activity lists, activity attributes, and milestone list. Project staff assignment, project scope statement, an output of defined scope in the project scope management knowledge area. Network diagram, remember, is an output of the sequence activities process here in the time management knowledge area. Risk register, an output of identify risks under the risk management knowledge area that we are going to discuss in a later presentation. Activity cost estimates, enterprise environmental factors, organizational process assets. What are the tools and techniques? Schedule network analysis, critical chain method, critical path method, resource optimization techniques, modeling techniques, schedule compression, leads and lags, scheduling tools. We are going to discuss a number of them, but remember, schedule compression and also leads and lags, they are very important concepts. Then let's now look at take a closer look at some of these items. Alright, we are going to focus on some of the tools and techniques. Schedule network analysis is a technique that generates the project schedule model. It employs various analytical techniques such as critical path method, critical chain method, what-if analysis, and resource optimization techniques to calculate the earliest and late start and finish dates for the uncompleted portions of the project activities. Alright, let's now look at the next tool and techniques used in develop schedule. One of them is critical path method. The critical path method, which is a method used to estimate the minimum project duration and determine the amount of scheduling flexibility on the logical network path within the schedule model. On any network path, the schedule flexibility is measured by the amount of time that a scheduled activity can be delayed or extended from its early start date without delaying the project finish date or violating a schedule constraint, and is termed total float. A critical path method critical path is normally characterized by zero total float on the critical path. Once the total float on a network path has been calculated, then the free float, that is, the amount of time that a scheduled activity can be delayed without delaying the early start date of any successor or violating a schedule constraint, can also be determined. Alright, let's now look at the critical chain method. Anytime the critical chain method is mentioned, think about buffers. The critical chain method is a schedule method that allows the project team to place buffers at any project schedule path to account for limited resources or project uncertainties. The critical chain method adds duration buffers that are non-work schedule activities to manage uncertainty. One buffer placed at the end of the critical chain is known as the project buffer and protects the target finish date from slippage along the critical chain. Additional buffers, known as feeding buffers, are placed at each point where a chain of dependent activities that are not on the critical chain feeds into the critical chain. Feeding buffers thus protect the critical chain from slippage along the feeding chains. Let's now look at resource optimization techniques, another important tool and techniques used in develop schedule. There are two optimization techniques we are going to discuss. One of them is resource leveling. Resource leveling is a technique in which the start and finish dates are adjusted based on resource constraints with the goal of balancing demand of resources with the available supply. It can be used when shared or critically required resources are only available at certain times, or in limited quantities, or overallocated, such as when a resource has been assigned to two or more activities during the same time period. Resource leveling can often cause the original critical path to change, usually to increase. Resource smoothing. Resource smoothing is another resource optimization technique used in develop schedule. Resource smoothing is a technique that adjusts the activities of the schedule model such that the requirement for resources on the project do not exceed certain predefined resource limits. Here, the project's critical path is not changed, and the completion dates may not be delayed. In other words, activities may only be delayed within their free and total float. Can you figure out the difference between resource leveling and resource smoothing? Yes. Resource leveling causes the original critical path to change. Resource smoothing, the critical path is not changed. Let's look at modeling techniques. One of them is what-if scenario analysis. What-if scenario analysis is the process of evaluating scenarios in order to predict their effect, positively or negatively, on project objectives. What-if scenario is of the form: what if so event, what will be the outcome, expected outcome. Simulation. Simulation involves calculating multiple project durations with different set of activity assumptions, usually using probability distributions constructed from the 3-point estimates to account for uncertainty. The most common simulation technique is the Monte Carlo analysis, in which a distribution of possible activity durations is defined for each activity and used to calculate a distribution of possible outcome for the total project. Schedule compression. There are two forms of schedule compression, or two types of schedule compression. Remember that schedule compression has to do with reducing the time spent on the scheduled activities or the total time it takes to perform activities in the schedule. One of the scheduling compression techniques used is called crashing. Crashing is a technique used to shorten the schedule duration for the least incremental cost by adding resources. Example of crashing includes approving overtime, bringing in additional resources, or paying to expedite delivery to activities on the critical path. Crashing works only for activities on the critical path, where additional resources will shorten the activity's duration. Crashing does not always produce a viable alternative and may result in increased cost and risk. Fast tracking. Fast tracking is another schedule compression technique. This technique, activities or phases normally done in sequence are performed in parallel for at least a portion of their duration. An example is constructing a foundation for a building before completing all of the architectural drawing. Fast tracking may result in rework and increased risk. Fast tracking works if only activities can be overlapped to shorten the project duration. Here are some outputs of the developed schedule process. We are talking about developed schedule, not estimate activity duration. So we are talking about outputs of developed schedule. One of them is schedule baseline. Schedule baseline is the amount of time that has been set aside for the project activities and is against which project performance will be measured. We also have schedule data, and we also have project schedule, project calendars, project management plan updates, project document updates. Let's take a brief look at schedule data. The schedule data for the project schedule model is a collection of information for describing and controlling the schedule. The schedule data includes at least the schedule milestones, schedule activities, activity attributes, and documentation of all identified assumptions and constraints. Information frequently supplied as supporting detail includes the following: resource requirements by time period, often in the form of resource histogram, alternative schedules such as best case or worst case, not resource labeled or resource labeled, with or without imposed dates, scheduling of contingency reserves. Schedule data could also include such items as resource histograms, cash flow projections, and order and delivery schedule. This is where we wrap it up on the developed schedule process. Join me in my next presentation as we are going to discuss control schedule. I hope you've enjoyed this, and I would like to thank you for watching.